2-3?
Yeah.
2-3. Hi, Brianna. This is section 2-3. We're doing multi-step equations. All right, here's the deal. We already know this, right? That if you are adding, that you have to subtract to the opposite operation. So like x plus 4 equals 6. If I'm trying to solve that, I have to do the opposite of add, which is subtract, not 2. Subtract 4, right? And I get x equals 2, yeah? If it's adding, I have to do the opposite and subtract, right? If it's subtraction, like x minus 4 equals 6, I have to do the opposite of that, which is add 4, right? And I get x equals 10, yeah? Okay, I'm going to go over here. If it's multiplication, like 2 times x equals, I don't know, let's say 10, right? I have to divide by 2. I have to do the opposite of that, which is division, and x equals 5, right? And if it is division, like x over 2 equals 10, that is x divided by 2, so I have to do the opposite of divide, which is multiply. And if I'm multiplying by 2, x equals 20 in that case, right? So I have to do the opposite. Now, the deal here is that we already know that stuff, right? Like that should be kind of a review. But when we have stuff going on like this, like here, we've got multi-steps. So we've got multiple things going on at once. And you're like, oh crap, which do I do first? Do I add the 6 over first or do I divide by 2 first? Okay? But which one do you do first?
You divide first.
So the deal here is, here's what I say. Ready? If I were to plug a number in for A, like let's say I'm plugging the number 3 in for A, would I multiply by 2 or would I subtract 6 first?
Multiply by 2.
You would multiply by 2. I want to go in the reverse order when I'm trying to undo the equation. So since I would multiply the 2 first, I'm going to add the 6 first to undo it. Does that make sense? Okay? So think about whatever's the farthest away from the variable first, right? Negative 6 or subtracting 6 is farther away from the A, right? So that's what I want to do first. Do you see how this works? Let me put them over here so we can go through all the steps. So we've got 2a minus 6 equals 4. We're going to solve them over here, okay? So, again, we're going to add the 6 first. Do you see why? If I plug a number in for A, we would multiply by 2 first. But we want to undo it, so we want to do the other one first, right? I'm going to add the 6 over, okay? And that gets him gone over here. So all I have left is 2a equals 10. And now I'm ready to go. Now I just divide by 2. And the answer is 5. Now, if I'm going to do that, and I got 5 as the answer, it's not a bad idea to plug him back in here and see if I get 4. So 2 times 5 minus 6, does that come out to be 4?
Yep.
2 times 5 is 10. Minus 6 is 4. It checks out, right? Okay, I can always check my answer. Good, good?
Yep.
Okay, let's go to B on the next page. Here is this. Woo! Okay. All right, here's the deal. On B, we've got some weird stuff going on, all right? The things that I need to move are this plus 1 and the negative 2, right? If I were to plug a number in for n, would I add the 1 or would I divide by negative 2 first?
Add the 1.
I would add the 1 first. So to undo it, I have to do the other one first. I have to divide by, or deal with the negative 2 first, okay? Dividing by negative 2, I have to do the opposite of that, which is multiply by negative 2. And that makes them go away, right? Times negative 2, okay? So I've got n minus 1 is just chilling. N plus 1 is just chilling. And 15 times negative 2 is negative 30, right? Okay? And then I'm going to subtract the 1. So n is equal to negative 31. Yep. Okay? Do you see how that works? When you're trying to solve for the variable, you do the opposite one first, right? Like if you were to plug something in. Okay? Good? Happy with that? That's kind of weird, like when you're undoing stuff like that, but that's okay. How many?
There's 3.
There's 3? Okay, let's do this check real quick. Do you want to try the check on your own? This one right here. 3m plus 4 equals negative 11. Do that one. Do that check on your own. See what you get. Okay? And it may not come out nicely. I don't know. This one does, actually. You what? Oh, you got it? Okay. Just wait a second.
I have no idea.
You have no idea? Did you try it? Did you get an answer? Did you try?
I got 1.
You got 1.
I got 1.
That's not even that.
All right. Here we go. The m is right here. So we have to move the 3 and we have to move the 4. Which one do you want to move first? The 4, right? Because if I were plugging a number in here, I would do the 3 first, right? So I want to do the other one. I want to subtract the 4 first, okay? So I'm going to subtract 4. He's gone over here. I have 3m is equal to, what's that come out to be? Negative 15, right? Negative 11 and negative 4 is negative 15. Now we're here.
Get 5.
Now I'm going to divide by 3. What's negative 15 divided by 3?
Negative 5.
Negative 5. Who got negative 5? Yeah, beautiful. Love it. Okay,
What about salt?
good? All right, should we do this one?
Yep.
Solve the other check. Okay? Figure out which one you do first. Okay?
Well, you're yappy.
It does not come out. Oh, yeah, it does. It's fine. It's fine.
It comes out nicely. It's a little bit of a bigger number.
It's a little bit of a bigger number, yeah. That's okay. That's okay. I'll give you a second, then we'll go through it.
What?
16.
Okay? Did we get an answer?
Wait.
No.
Wait.
I did that wrong.
One sec. That's what I just thought. I think Cole did it wrong.
Okay.
It's 6 away.
I think this is wrong, but
I think this is there we go. That
Oh,
this
man.
one's awful.
Oh, man. Oh,
That's
man.
what I got, but then I was like, I did it wrong.
All right, so X is here. We have a minus 5 and divide by 7 first. Which one are you going to do first to go to the other side?
Add
No, multiply
If
by
I
7.
if I were to plug a number in, would you divide that number immediately by 7 or would you subtract the 5 first?
Subtract
You would subtract the 5 first, so I want to do that last, right? I want to deal with the 7 first. So how do I get rid of the 7? Multiply by 7 to the other side, right? I'm going to get rid of him. What's 8 times 7? 56 equals X minus 5. Now to get rid of the 5, I
Add 5.
add 5. Right, add 5. So X is equal to
61.
61. Did you get 61?
Yep.
Yeah.
I got that first and then I changed it.
Okay.
Hayden.
Good, good. All right, example 2. Write and solve a multi-step equation. Holy moly. The student council raised 2/5 of, what's the word of mean? Times the money they needed to cover the cost of the school dance with a bake sale. They raised an additional $150 selling raffle tickets. If the student council has raised $630, what is the cost of the total dance? All right, so let's go back to the very beginning. 2/3 of the money that they need. 2/5 of means times the money that they need. What should we call that?
Cost.
M.
I'm gonna say N, because that's money needed. Whatever variable you want to use, I don't care. Okay, 2/5 N. That's what they did with the school day or with the bake sale. Then they raised an additional 150
Plus 150.
plus 150, and that all together ended up being 630. Okay, do you see how that works? They use the words is, like if the student has raised. Okay, they didn't use the word is. Sorry, that's just equals 630. Questions about that? Okay, N is over here, right? I have a 2/5 and I have a 150, okay? If you would plug a number in for N, would you multiply it by 2/5 first or would you add the 150?
Multiply.
I would multiply, so I want to do that last. So I'm going to get rid of the 150 first, right? So I have to subtract 150, right? Minus 150. Okay, and this is 2/5 N equals, what's that? 480. Okay. All right, now, how do I get rid of the 2/5? I'm going to divide by 2/5, or dividing by 2/5 is kind of like multiplying by the reciprocal, which is 5 over 2, right? Okay. Now, 480 over 1 times 5 over 2. I'm going to reduce the 2 in the 480. What's 480 divided by 2? 1 and 240, right? So N is equal to 240 times 5?
Yep.
1,000 plus another 200, 1,200.
That's what I got. I just did that.
So $1,200 is how much they need for the school dance. That's a lot of money. What are they doing? School
We made that
dance?
in almost one day.
For concessions.
The concessions.
Yeah.
Last year. For you and
Right, yeah, subtract out all your stuff, yeah. Okay, good?
Last year's concessions.
$1,200 is how much they need for the dance, right? Okay, and then there's all their work. All right, go to example 3.
$3,000
Example 3, here's what we have. Some equations have coefficients that are represented by letters. To solve these equations, apply the process of solving equations to the isolated variable. Ooh, okay. So they want us to solve this equation for x, okay? Now this is a little bit confusing because a is supposed to be a number. So treat that like it's a number, right? Okay? And we're going to do this exactly the same as what we had before, right? Okay? So I'm going to, do I have room over here? Yeah, I do. So ax plus 7 equals 5, okay? And I'm still solving for x. Just treat that a like normal, okay? Just deal with the a. So if I plug a number in for x, would I multiply by a first or would I add the 7?
Multiply by A.
I would multiply by a first, right? PEMDAS, and multiplication comes before addition. So I would multiply by a first. So that means I want to do that last. And I want to deal with the 7 first. So I'm going to subtract 7, right? Subtract 7, okay? So a times x is equal to, what's 5 minus 7? Negative 2. Okay, now, to get the x by itself, how do I get rid of that a?
Divide.
I'm going to divide by a, and that's just going to look kind of funny. And my answer is going to be negative 2 over a. And that's it. I don't have like an actual number answer. I just have a in my answer. Does that make sense? You just do the steps just like you would, but it's not going to come out nicely. Okay? So that means the reason why we do that is because maybe they're charging $4 per ticket, right? Okay? So then it would end up being like that, right? But maybe at the last minute they decide to charge like $8 per ticket, right? Then all I have to do is come down here to the answer and plug an 8 in, right? So this is really nice to have it solved for when I want to switch out that number, like $8 per ticket, $12 per ticket, $4 per ticket, whatever, right? I know. It's not a very good story problem, but like that's a time where that's applicable is when you would like swap out the answer and you'd already have that ready to go. So you wouldn't have to solve it every time when your number was different, right? Okay, so negative 2 over a. Do we have another story problem? No, that's it, right? Is that it? Should we do this one? Let's do the check. We're solving for which variable? Which thing are we solving for? We're solving for x, right? Okay. All right. So if I had, so we got a 2 and an a we got to get rid of. Which one are you going to deal with first?
2.
The 2. How are you going to get rid of the 2?
Subtract.
Because it's not a negative. It's not negative. The A is negative.
Ah, this is a good one because I see people with a negative right here and they're like, oh, I have to add that 2 over. But the 2 has a positive in front of it, right? So I have to subtract this 2, right? And I'm going to subtract 2 over here. So what's left on this side of the equal sign? What's over here? Negative ax, right? Don't forget the negative goes with the a, not with the 2, right? We're getting rid of the 2. And over on the right side is negative 10. Okay, then I'm going to get rid of and to get the x by itself, I have to divide by negative a, right? So that cancels out. I'm going to divide by negative a, okay? So what is negative 10 divided by negative a?
10 divided by A.
Yeah, the negatives can cancel, so it's just 10 over a, or 10 divided by a. Yeah? Okay.
Is it okay if we put negative?
What do you mean?
They're not working.
Negative 10 divided by negative a?
That's an answer.
But the negatives will cancel. So go ahead and write them as a positive.
So it would just be 10.
10 divided by a. 10 over a. Yeah?
The negatives
Okay.
cancel.
The negatives end up canceling. Yep. Okay? Yes, 2 negatives make a positive. Good? Anything else? Okay, let's have you do, let's see, that's example 2, example 3. Oh my gosh, we're going to be like all on one page. Let's have you do 2 through 26 evens. We'll make it short, kind of. It's only the first page. That's only the first side. Page 89. 2 through 26 evens. There you go.
8, 10, 12, 14, 16,
18, 20, 32, 46, 78, 91.
Hold on.
I screwed you up. Oh, that's what I wanted to do.
26.
There you go. All right. Goodbye, Brianna. You guys